We're going to have a look at converting a standard to second report, tidal height and times. Our example is the 19th of February, and we're going to look up the heights and times of high and low water for the port of Crookhaven on that afternoon flood tide. You'll be given what's called the ATT, the Admiralty Tide Table number, and in this instance it's 741. So first of all, you go into the back of the tide tables and have a look and find 741 Crookhaven. And you can see that it's not in capital letters, therefore it's not a standard port. We go to the nearest one with information and we see that Cove, Ringaskiddy, is our standard port. So that's the first thing we need to establish. Is it a secondary port or is it a standard port? So we've established that it's a standard port. Now we go to the main page for Cove and we look up the 19th of February. So we go to the main page, go down to the 19th of February and write down the relevant information. And we're looking for the tide 1501 to 2054. So what I've done, I've printed it there and I've picked it out, 1501, 2054, low water, high water. So that clearly indicates that it's actually a flood tide. We're not covering plotting anything in this video, but it's worth noting that at this point you must get the daily range. The daily range is always taken from the standard port information. So in this instance our daily range would be 3.1, and where that's important is that when it comes to plotting, then it tells you whether you're going to have to interpolate between neaps and springs. And of course, if we were doing a plot, we would do here because it's 3.1. So that's why you get the daily range, and it's very important that it's always the standard port information. So now we're going to look at converting the heights and times for Crookhaven. So times of high water and low water. So if we look in the back of the book again, you'll see at the top time differences, high water, low water. I'm going to look at low water first, and you'll see we've got 5, 11, 17, 23, and for Crookhaven we've got a correction of 48 minutes minus and 1 hour 12 minus. They're the corrections for Crookhaven. So I've printed it out here, high water and low water, and we extract 5, 11, 17, 23, and this is a 24-hour clock. So between 5 and 11 you would go this way, 11 to 17 that way, 17 to 23 that way, 23 to 0500 that way. Our time is 2054, so we'll move between 17 to 2300. So let's have a look at the information there. So there's Crookhaven there. High water, we're going to do high water now. High water is 57 and 33. Correction, of course, low water 48 and 112. So we're going to look at these two pieces of information plus the time differences there. It's worth noting that they're not always the same, these time differences. The clock, I should say, 5, 11, 17, 23. They're not always exactly the same for both. So we've gone in the tables. Our high water time that we picked out initially is 2054. So we will move between 17 and 23. Okay, because our time is 2054. So we'll go from 17 to 23. And therefore our correction will be between 57 and 33. So I've printed it off here, 57, 33, 17 to 23. So doing the maths, between 1700 and 2054, because I'm going this way with my interpolation, is 3 hours 54 minutes. I'll convert to minutes, 2, 3, 4. 17 to 23 total is 6 hours 360. And the difference between our corrections, because that's what we're looking for this value here, is 24 minutes. So do the maths and you find 16 minutes is the value. So we're going to go 16 minutes from there towards there, and it gives us a correction as minus 41 minutes. So high water at Crookhaven will be 2054 minus 41 minutes, 20, 30 knots. Now let's look at low water, which is the same principle. We get the low water clock and we write down our low water time. It's 15:01. So in this instance we'll go from 11 to 17. 1500 or 15:01 falls between 11 and 17. So when we do our interpolation, we'll go from right to left now instead of left to right, which is what we did with high water. So here we are, low water. We've written down the values. 17, 1100, 11 to 15:01 is 4 hours 1 minute. 11 to 17 is 6 hours. 241 over 360 multiplied by the difference between the two low water corrections gives us 16 minutes. So we will go that way with our correction now, that way, because we've gone that way with the clock, and it'll give us minus 56 minutes. So low water at Crookhaven will be 15:01 minus 56, 14:05. Of course, you don't really need to calculate low water when you're doing a tide problem, but sometimes they might ask you to do all the tides for that particular day. So now let's look at the heights. Just want to point out here that we can't be more accurate than the tables, so we would only work to 1 decimal place. Okay, and there are 3 corrections. The first correction is what we call our seasonal correction for the standard port. So we go into the bottom. We go to the bottom of the page, of the tidal book, and there we are. Just briefly show you there, the bottom of the page where it says seasonal changes. I've printed them off here, and we look up code, which is ATT 751 for February. So we find the ones between the two that are either side of 751. Go to February, and you'll see that it's 0. So we must write in the seasonal correction of 0. It's worth pointing out for the standard port, if our example had been 0.1 plus, we must change the sign. So whatever correction you get for the standard port, for the seasonal correction, change the sign. So now we put our seasonal correction in, and you can see our low and high water values haven't changed. Now we come to our main correction, and the important information to get now for COBE: mean high water springs and neaps, mean low water neaps and springs, the dark print, the 2 there, the 2 there, and of course our corrections for Crookhaven. So that information is what we need to solve the problem, and I've printed it on the page here. 4.2, 3.3 for high water, 1.4, 0.5 for low, and the corrections are given there. Okay, so what we'll do the low water main correction first. Okay, so 1.4 and 0.5 I've written here, 1.4 and 0.5. Low water at the moment is 0.8 after we've applied the seasonal correction, and our actual corrections for Crookhaven minus 0.4 minus 0.1. 0.5 to 1.4 is 0.9. 0.5 to 0.8 is 0.3. So I'm going that way with the correction, multiply it by the difference between these two, and I get a value of 0.1. Low water main correction will be that way, 0.1, so it's going to be minus 0.2. Minus 0.2. Now let's look at the high water. 4.2, 3.3. 4.2, 3.3. R value 3.9. Minus 0.8, minus 0.6. Again, do the maths. Correction is 0.1. We've gone that way, so the correction will be minus 0.7. So we put both corrections in there, and then we carry forward the values 0.6 and 3.2. The third correction is the seasonal correction, and this is the correction for the secondary ports for Crookhaven. And we do not change the sign. Don't change the sign. So again, go to February, and in this instance it's again 0, but had it been a value, we would have put it in as it is and not changed the sign. So we can see we've ended up with Crookhaven heights of 0.6 and 3.2. So it's worth pointing out that had you not taken the daily range when you were plotting there and taken it there, you would have been incorrect, and it would have been a principal error. So we always take the daily range from the standard port values.